Hang on. Okay, we're live. Hi.
Hello, we're here.
Hello.
All right, this quiz is 17 questions. All right. 1. Difficult one. 2. Just kidding. All right. First 2 we got right. Number 3. You guys ready?
Yep.
Mm-hmm.
In a pie chart, why are the slices or sectors different sizes?
And from the number
Each
2.
slice.
Each slice represents a category. Yeah.
Yeah.
Each slice represents a proportion of the total occupied by the category. 4. How are bar charts and Pareto charts related?
It's
The
the
last
One
one.
is the only different, yeah.
One has order, the other one is just
Random.
We conclude that P, how do you say that?
P hat.
P-hat.
P hat? Okay.
Yeah.
The P with the hat is normally distributed if NP is greater than or equal to 10, and N, 1 minus P, is greater than or equal to 10.
So N is the size of the study, and P is the null hypothesis in that situation, correct? That's what I
And P.
I know that doesn't make sense because normally P is that proportion,
Proportion.
but in NP status, it means the size of the null hypothesis.
Yeah, that's true. Yeah, it's a true proportion, right? Oh,
Yeah.
is it the true proportion or sample proportion?
Is it sample proportion?
It is, yeah, the sample proportion, you're right.
Yeah.
Yep.
And
Okay, sorry. So 6. So 5 was sample proportion.
Yes.
6. What is N? N
The
is
sample size.
Okay, this is easy. 7. If P equals 1 over 4, what is the smallest N that satisfies the requirement? Fourth, so 0.75 times N.
what's the equation to figure that out? Is that the N
So
times
10
1?
divided by 0.75, right? What we're getting at?
How did you get that?
1 second. So we've got, so this is what, lesson 16. 16, okay. So we've got N times 1 minus P greater than or equal to 10. And so
Yeah.
P equals 0.25. We've got N times 1 minus 0.25, which is 0.75, which is greater than or equal to 10. So you divide both sides by 0.75, so N equals, so N is greater than or equal to 10 over 0.75. So that 10 divided by 0.75 to give you 1 N. Right?
Yeah, that sounds good.
So what did you say that was? 0.75?
Yeah. Which means, that makes sense.
No, that makes algebra, right? You just moved it
And
around.
N can't be a 0.3, so you'd have to round up to 14, right? So
And what was the calculation you did? What was the N times?
Actually, take it slowly.
here. So with the equation of so we have P hat is normally distributed if you've got NP is greater than or equal to 10.
Yeah.
So I just took N times 1 minus P is greater than or equal to 10, and then just plugged in
Oh, they give it to us right there.
So 0.25. So you can use either equation, I guess, right? One of them is 10 over 0.25. The other one is 10 over 0.75. So I don't know.
If you divide both sides by the 0.7 again, so it's 10 divided by 0.75 is the answer. Where's my phone?
So does that sound good to everybody? 14, right, is what we would end up getting? Because we got 13.333, we'd round up to 14.
No.
Is that for 7 or 8?
Would you round up or no? Wouldn't it just be 13?
Well, for sample size, I don't think you can do a portion of something and all the other equations round up to.
Yeah, 13 would be too small. It would be less than. It
Yeah.
wouldn't be. It would make the equation false. So you'd have to round up.
Okay.
Does that make any sense?
Yeah, we went over that in the.
Yeah.
Okay. So 7.
Yeah, they did go over that.
The 7 sound good for 14, or 14 can sound good for 7.
Yeah.
Okay. If anyone feels differently, just please call me out. Let me know. Use the following information to answer questions 8 through 9. Suppose n equals 24 and p equals 0.4. Okay. What is the mean of p hat?
Isn't it 0.4?
Yeah.
P hat equals x over n, where x is the number of individuals with a certain. So based on that information,
When we look at like z equals the value minus the mean over standard deviation, it shows p hat minus p. So this is
Yeah.
right?
I have p hat equals x over n, but I'm
I
not.
think that's how you find it, but on the notes it says that the mean of p hat equals p.
Okay, I like
Yeah.
that.
Yeah, that's what I have written down.
So how do we figure out the deviation?
The standard deviation?
It's the square root of p times 1 minus p all over n, right?
Yeah.
So 0.4, correct, for 8?
Yes.
Yeah.
Standard deviation, okay. Standard deviation is the square root of p times 1 minus p over n, right?
Yes.
Yeah.
0.4
Over 24.
times 0.6 all over 24.
I got 0.1.
That sounds right. So 0.4 times 0.6 divided by 24 is 0.01.
And then you take the square root, right?
Square root of that.
So you got 0.1?
Yeah. What'd you get?
Okay, that's what I got.
0.1. Using the following information to answer questions 10 through 13, Brittany's batting average is 300.300. We want to determine the probability she'll get more than 35 hits in her next 100 at-bats. So we've got n equals 100, and p equals 0.3. So the probability that she'll get more than 35 hits in her next 100 at-bats.
So it's 10 to 0.3.
So more than 35 hits? That means 36 is x? Turn final probability.
Isn't that just the z-score? Not the z-score. What is it? Oh,
P hat equals
Yeah.
X over N. So are we? So 36 is the number, right? Because we want to get more than 35.
yeah. So you just shade everything on the normal probability output.
So 36 over 100 to give us the P hat. Does that sound right?
I thought it was 35 over 100.
I know, it's just worded really funny.
I thought that we had to find. Sorry, I thought we had to find the z-score for it. So we because you do more than 35. So then you find the z-score for 35, and then you would find what the area is to the right
To the right, yeah, for more.
for more than 35.
The z-score, that's question 12.
Okay.
So 10 is just X over N equals P hat. 11 we do standard deviation, which is P times 1 minus P over N, square root all of that. And then 12 is the P hat minus P over
The square root.
the square root of P times 1 minus P over N. So it just gets progressively more crazy.
Yeah, do you guys ever listen to ourselves and think, what are we doing?
I know. I was listening to this. Yeah. Now I understand. Like, it's a whole other language.
So is XR 0.30?
Ten P hat is 0.25.
Say that again.
0.35. Because it's 35 over.
Got it.
35 over 100.
Yeah.
So 0.35.
Yeah.
Okay. Okay. And then 11 is 0.3 times 0.7 all over 100, and the square root of that entire thing. Right?
0.0477. Or I guess 0.048.
Zero 0.04582.
I got 0.048.
So did you guys take 0.3 times 1 minus 0.3, so 0.3 times 0.7. So let's walk through it.
You mean
0.3 times 0.7 is 0.21.
No. Wait. So 1 minus 0.35 is not 0.7, it's 0.6.
But P is 0.3. We're not using P hat, we're using P in order to find the deviation, right?
I'm glad we're all
Yeah.
here. Yes, I was wrong. I used P hat again.
Okay. So we have 0.3 times 0.7, which is 0.21. 0.21 divided by 100 equals 0.0021. Square root of 0.0021 gives us 0.0458.
458.
So if we're doing 3 decimal places,
Or 6.
0.046.
Yeah.
And what is the z-score? So to get the z-score, it is p hat, so 0.35, minus p, 0.3, over the standard deviation, which was 0.04. I'm just gonna, so we get a more accurate answer, 0.04582.
Wait, what was so for question 9, what was our standard deviation?
0.046.
So for 12,
Oh, sorry. That was number 9. I got 0.1.
Oh, okay.
0.1 was the standard deviation for 9.
Yeah.
10 is 0.35. 11 is 0.046 after rounding.
Correct.
4.
1.091. Is that what you guys got?
I got 1.091.
Yep, that's what I got.
Okay. Let's do that. .091. Okay, 13. What is the probability Brittany gets at least 35 hits in her next 100 at bats? So that's funny. The question originally is she'll get more than 35, but the probability that she'll get at least 35. An error in her question, and the questions, of course. Okay, so 13. What is the probability in her next 100 at bats? So the probability, 1.091 for z-score. So now we go to the probability applet, correct?
Yeah.
And z-score 1.091.
Yeah.
And is it greater?
It's always to the right, right?
Yeah. So 0.1376.
376.
138. 0.138.
Yeah. 0.13.
14. If the true proportion of people who support a political candidate is P equals 0.52, and N equals 2,000, write this down, people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What is the standard deviation of P hat? Standard deviation, P hat, is P, so 0.25, 0.52, sorry, times 1 minus 0.52, so times 0.48 over 2,000, and we want to square root the entire thing. So 0.52 times 0.48 divided by 2,000.
You had 0.01117.
Yep. So 0.011.
Yeah.
0.011, yeah.
Yep.
Okay.
That.
What z-score would you use? So with that, we take P hat, which is X, so 50, right? Is that what we're using? Percentage?
No, isn't it just P hat minus P over?
I know, but in order to get P hat, we don't have P hat yet. So we have to get P hat to get
Oh,
to
you're right. Okay.
For P hat, we would use X equals 50, right? Because they said less than 50, but they want 50, right?
Yeah.
Okay, so we use 50. So 50 over 2,000. .025. Okay, so then you take 0.025, you minus P.
Which is 0.52, right?
52.
Yeah.
And you put that over 0.011. Right. So we've got 0.025.
I got negative 45.
Me too.
16?
Me too.
That doesn't seem right.
That doesn't seem right.
I think that our p-hat's wrong.
Oh, you know what's wrong? So n equals 2,000. Less than 50% of the votes, we would say 1,000 is 50%.
1,000.
So x should be 1,000.
Okay.
1,000 over that, so 0.5, right? That we're talking about. So 0.5 minus 0.52, so you get 0.02, negative 0.02 over 0.011. So
then our real z-score is negative 1.818.
negative 1.818.
I don't even understand 16's answers.
Okay. What probability do you compute using the normal probability applet?
Oh, so it'd be less than, right? So then, like, everything to the left of the z-score, what does that make it? 0.0345?
Yeah, but the answer for 16 is weird. Like it says p parentheses big Z greater than or equal to little z. Like I don't even know what that means.
Go get it, hurry.
I got the same applet score. I got 0.0345, which would be 0.0355.
I got 0.0345. What did you get?
I got the same.
So, getting less than 50% of the votes and negative 1.818. We plug that in. 1.818. Bam. So we want to do less than that, right?
Yeah.
So it's to the left of that.
Yeah, but look at what our answers are.
0.0345. But he's just looking to get 0.5, less than 0.5, but we're far less than that. So
Was it the big Z is greater than or the little Z is greater than?
So on the notes,
which one's big Z?
I don't have any notes.
the only thing I see is it says p times p hat like is greater than 0.5. So then
I think big Z is what they're assuming, and little z is the actual. If we figured it out, right?
I have no idea. I don't remember reading it. Justin, any?
I have no idea. That I did not read or see anything that looks that familiar.
Does that sound right? I mean, we're trying to. You call that.
You really don't have a blanket?
Yes.
Gonna find it.
No, it's 17 0.035.
let me see. Yeah. You can see.
Any thoughts?
Is this for 16 or 17?
Well, I think that 17 was what we got on the X. 0.035. But we just need to decide what best describes that. So looks a lot like the P times 1 minus P. So could these represent each side of that equation?
So when we punch it in, it's 0.0345, so 0.035, right?
Yeah.
So that's 0.035, which is less than 0.52. Or whatever, 0.5 or whatever it is up there. So I would say that big Z,
Okay, so
which is true, is greater than or equal to little z.
so if you go to the notes on the very bottom, right before the summary, it kind of gives a sample.
Yeah, that's what I've been looking at. I think that's.
Okay, then yeah.
I'm gonna submit mine. Right there. I got an 84. And we were right about the
Oh.
We were right about what?
We were right about the Z1. We were wrong about a couple.
Well, I got a 78 somehow.
That's what I got.
I got an
Wait,
80.
so
So P is the proportion of, is the true proportion for 5. 7 we got wrong, so apparently that's not how you're supposed to figure out the smallest n. 15, for some reason we got the wrong z-score. Somehow.
Yeah,
And what probability do you compute? P of z less than or equal to z.
I got that one right now. The big Z is less than or equal to little z.
That's the right answer.
Yeah, I told you guys that.
Oh.
I'm sorry.
All right, can't go change it now.
Okay, so hang on. I'm going to stop the broadcast and post it. I'll see you guys soon.